A very good afternoon to all of you. Myself, Kedarnath Vai, lecturer in Electrical Department at Government Polytechnic, Raichur, from the Department of Collegiate and Technical Education, Bangalore. In this session, I will be discussing a few topics of Unit 2, that is Digital Principles, from the subject Digital Electronics. I wholeheartedly welcome you all for this wonderful session 9. In this session, I will be discussing three major topics. Number 1, hexadecimal addition. Number 2, hexadecimal subtraction. 3, advantages of hexadecimal number system. First of all, we will discuss what is a hexadecimal number system. The name indicates that it is a hexadecimal number system. Hexadecimal means 16. The base in this number system is 16. This 16 indicates this number system as 16 characters or 16 digits. They are from 0 to 9 and from A to F. 0 to 9, they are 10 digits, and A to F, they are 6 digits. In overall, so in hexadecimal number system, 16 characters will be there. In this slide, we have two examples, example A and example B. In example A, conversion from binary to hexadecimal number system, and in example B, conversion from hexadecimal number system to binary number system. I will not be discussing more about these topics because after my class, session 11 and 12, in session 11 and 12, these topics will be discussed in more detail. So therefore, example A is the 4-bit binary. Here, 4-bit binary is converted to equivalent hexadecimal number. And in example B, a hexadecimal number is converted to its equivalent 4-bit binary numbers. Let us move to the next slide. The below table shows the relationship between decimal, binary, and hexadecimal. First column is a decimal number system. Second column is a 4-bit binary system. And third column is a hexadecimal number system. From this table, by seeing the table, it clearly shows that there is a relationship between decimal, binary, and hexadecimal number. First column is a decimal number from 0 to 15. Second column is a binary number system with 4 bits expressed from 0 to 15. And third column is a hexadecimal number system expressed from 0 to F. So from this table, we can learn how to convert a decimal number to its 4-bit binary and how to convert a decimal to its equivalent hexadecimal number. So in simple, we can say decimal equivalent of binary and a decimal equivalent of hexadecimal is given in this table. First topic of this session is hexadecimal addition. In this case, we are supposed to add two numbers, that is hexadecimal numbers. We have to add two hexadecimal given numbers. The addition of or the sum of two hexadecimal numbers will also be a hexadecimal number. The name indicates hexadecimal addition. By the name itself, it understood that hexadecimal. We are not doing addition in hexadecimal. Instead, we are doing addition, or we are performing the addition in decimal. First, the given hexa is converted to decimal. Then addition is done in decimal, and after that step, the decimal equivalent is converted to hexadecimal, and finally the answer is written. So hexadecimal addition. The sum of two hexadecimal digits is same as their equivalent decimal sum, with any sum from 10 through is expressed as a letter A through F, provided the decimal equivalent is less than 16. So here, in simple way, we can say the sum of two hexadecimal digits. If the sum of two hexadecimal digits is 16 or less than 16, we write the hexadecimal equivalent of that sum. But in hexadecimal number system, we express the digits from 10 to 15 as A through F. Suppose if the sum of first two LSB digits is greater than 16, subtract 16 to obtain the hexadecimal digit, and a carry 1 is sent to the next digit for addition. That means if the sum of two LSBs is greater than 16, if that is the case, we have to subtract 16 from the sum, and a carry of 1 will be sent to the next higher bit for further addition, because in hexadecimal the maximum characters will be 16. So therefore we are subtracting 16, and finally we are sending a carry to the next higher bit for addition. So let me see here steps to perform hexadecimal addition. So what is the first step? Add one column at a time. That means for performing the hexadecimal addition, we should add. We have to take one column at a time. That means LSB of first hexadecimal number and LSB of second hexadecimal number. Convert the decimal and add the number. I already told you the name of the topic is hexadecimal addition, but indirectly we are doing the decimal addition. Hexadecimal numbers we are converting to decimal and then performing that addition, then again converting the decimal number to its hexadecimal, and finally the answer is written in hexadecimal. So here we have two conditions for addition of hexadecimal numbers. If the result of step 2 is 16 or larger, subtract result from 16 and carry 1 is sent to the next column. I already told this topic. So if the result of step 2 is less than 16, convert the number to hexadecimal. Okay. So if the result of the two LSBs is less than 16, you can write the equivalent hexadecimal of that sum and write it in the sum bit. So let me see here example 1. So here we have to perform hexadecimal addition. The given two hexadecimal numbers are, first one EE-15EE34T-U2-S9 plus EE-15EE34T-U2-S9. We have to perform addition in hexadecimal. So let me read out here. So the problem, you have to add these numbers. We have to perform addition of two hexadecimal numbers. So here how many steps are there totally? This is step number 1, step number 2, step number 3, step number 4, step number 5, and step number 6. So similarly, this is step number 1, step number 2, this is step number 3, 4, 5, finally 6. 6 steps are there. Okay. So for addition, first we have to consider 2 bits. Which 2 bits we have to consider? See, let us take the LSB of first hexadecimal number. The LSB of first hexadecimal number is 9. The LSB of second hexadecimal number is 5. In the first step, we need to add 9 with 5. So let me see what he has written. Add one column at a time. That means we have to take LSB of first hexadecimal and LSB of second hexadecimal. We have to add the two LSBs. So before adding, we have to convert the given hexadecimal number to its equivalent decimal value. So therefore, so what already 9 and 5, they are the decimal equivalent. Okay, so therefore, so no need to convert to decimal. So 9 will be same in decimal as well as in hexadecimal. 5 will be same in decimal as well as in hexadecimal. No need to convert to decimal. So in the first step, 9 is added with 5. 9 plus 5, it will become 14. So 14. So the decimal equivalent of 14 is E. So therefore, so decimal 14 is hexadecimal E. So here the answer of step number 1 is E. So let us go to the step number 2. So in step number 2, what is given? So in step number 2, we are supposed to take A with 7. We are supposed, that means step number 2 is A plus 7. Okay, so the same thing it is written here. Add next column. Convert to decimal and add. So that means A is converted to decimal. The decimal equivalent of A is 10. 10 plus 7 is how much? 17. So here we cannot write 17 as it is because 17 is greater than 16. Okay, so here we have to subtract 16 from 17 so that we get here difference is 1. So therefore the right answer 1 here, and you take carry 1 to the next higher bit. Okay, why we are taking carry? Can you tell me? Because we are subtracting 16 from the 17. So therefore, since we are subtracting 16, so therefore we have to take carry of 1 to the next higher bit for further addition. So what is the 17 minus 16? It is 1. So the difference of that means the answer of step 2 is 1. So let us go to the step 3. So in step 3, we are supposed to add 5 and 6. But 5 and 6 should be added to again carry, because from the previous step carry has been generated. So therefore step number 3 is what? Step number 3 is convert to decimal and add. So 1 plus 5 plus 6. So 1 plus 5 is how much? 6. 6 plus 6 is how much? 12. Okay. So the hexadecimal equivalent of 12 is C. Since 12 is less than 16, no need to subtract. So we cannot write 12 here. Instead, we have to write the hexadecimal equivalent of 12 in the step number 3. So therefore, what is the answer for step number 3? C is the answer for step number 3. In step number 3, no carry is sent to the next higher bit. So let us go to the step number 4. So in step number 4, we have to add C with A. So this is the step number 4. We have to add C with A. So here, so C with A. So here, this is step number 4. So the decimal equivalent of C is 12. And then the decimal equivalent of A is 10. So therefore, C plus A, 12 plus 10 is how much? 22. So since 22 is greater than 16, therefore we have to subtract 16 from 22. And finally, the difference answer is 6. So here, the answer for step number 4 is 6. And we are sending a carry 1 to the next higher bit. Why? Because we are subtracting 16 from the 22. So therefore, since we are subtracting 16 from 22, therefore we have to send carry to the next higher bit for further addition. So let us see, this is which step number? This is step number 5. In step number 5, what we should do? So in step number 5, we are supposed to add B with A and a previous carry. See here, there is a small changes is there. This is a carry. It is shifted at a far distance. Actually, this one should come above B. Step number 5 is 1 from previous carry plus B and A. 1 plus B plus E is step number 5. So 1 plus B. So B means the hexadecimal equivalent of B is 11. The hexadecimal equivalent of E is 14. So therefore 1 plus 11 is 12. 12 plus 14 is 26. So since 26 is greater than 16, so therefore uh, 26 is greater than 16. Therefore 26 minus 16, we have to, so sorry, once again I'm repeating. So step number 5. So 26 is greater than 16. So therefore subtract 16 from 26. We get here how much? 10. So the hexadecimal equivalent of 10 is A. So the answer for step 5 is A. But carry is there. So we have to send carry. So we have to send carry. So here we are sending the carry. Okay. So this carry, so it is sent to the step number 6. So in step number 6, we are supposed to add 1 from a previous carry, 1 plus 0 plus 0. That is finally the answer is 1. The answer of step number 6 is 1. So finally the solution for example 1 is 1A6C1E. So this is the answer. I hope you have understood the example 1. Okay, suppose if you have any doubts, so you can clarify that doubt in the example 2. So let me explain example 2 in a slow motion. See, this is the example 2. The same hexadecimal addition. C4BDF plus E2CA9. Okay, so for what is step number? This is step number 1, F plus 9. Step number 2 is D plus A. Step number 3 is B plus C. Step number 4 is 4 plus 2. Step number 5 is C plus C. So let me see in detail. So in step number 1, so F plus 9. So what is the decimal equivalent of F? 15. So step number 1 is, instead of F, we have to add 15 plus 9. 15 plus 9 is 24. So since 24 is greater than 16, so therefore you have to subtract 16 from 24. So 24 minus 16 is how much? Again, the answer is 8. So this is the answer. 8 is the answer for step number 1. So in step number 2, we have to take carry from the step number 1. Okay, so why, can you tell me why we are sending the carry to the next higher bit? Because the sum of two LSPs of both the hexadecimal numbers is greater than 16. If that is the case, we have to send carry after subtracting 16 from the sum bit. Okay, so in step number 2, 1 plus D plus A. So this is the step number 2, 1 plus D plus A. So 1 plus D. So what is the value of D? The value of D is 13. 1 plus 13 is how much? 14. 14 plus A. A means 10. 14 plus 10 is 24. 24 minus 16 is how much? Again it is, since 24 is greater than 16, therefore you have to subtract 16 from 24. So that after subtraction, the answer is 8. So since I'm subtracting 16, I'm sending carry to the next higher bit for further addition. Step number 3, we have to add 1 with B and with C also. So therefore step number 3 is 1 plus B plus C. 1 plus B plus C. 1 plus B is how much? 13. So 1 plus 13, how much it is? 14. 14 plus C value is, what is the value of C? The 12. So that is again 20. So here 1 plus B plus C. 1 is added with B. 1 is added with 11. So it is 12. 12 plus C. 12 plus C is again 12. 24. 24 is greater than 16. So therefore subtract 16 from 24. So you will get here 8. So since we are subtracting, again we are sending the carry. So in step number 4 is 1 plus 4 plus 1 plus 4 plus 2. 1 plus 4 is 5. 5 plus 2 is 7. Okay, since 7 is less than 16, no need to subtract. I'm writing 7 as it is in the step number 4. Okay, so the answer of step number 4 is 7. So let us go to the step number 5. So here C plus E, step number 5, C plus E. C, what is the decimal equivalent of C? The decimal equivalent of C is 11. The decimal equivalent of E is how much? 14. So here 11 plus 14. So 11 plus 14, how much it is? So the value of C is 12. So C is 12. 12 plus C. 12 plus C, that is 12 plus 14. That is 26. 26. Since 26 is greater than 16, so therefore 26 minus 16 is how much? 10. So we cannot write 10 here. Instead of 10, I am writing A, because the A is the decimal equivalent of 10 in hexadecimal number system. I'm sending carry 1. So here we have 0 and here we have 0. So in step number 6, 1 is added with 0 and that 1 is added with 0. So finally the answer is 1. So the answer for example 2 is 1A7888. Okay. I hope you have understood the example 2. So the major second topic of this session is subtraction in hexadecimal. Hexadecimal subtraction. So what is the problem given? 569D minus FDA. You have to subtract these numbers. 569D is the minuend. FDA is the subtrahend. The number, the hexadecimal number which you want to subtract from the other number, that number is called as subtrahend. Okay, subtrahend. So therefore the question given is 569D minus FDA. Okay, so first we have to write, so here how many steps are there? Step number 1, step number 2, step number 3 and step number 4. So this is step number 1, this is step number 2, step number 3 and step number 4. So step number 1, step number 2, step number 3 and step number 4. So here in step number 1 we are supposed to add D with A. We are supposed to add D with A. So we cannot add D as it is with A. So when you want to subtract, we have to subtract in decimal, not in hexadecimal. So what is the decimal equivalent of D? So this is the step number 1, explanation about step number 1. So the decimal equivalent of D is 13 and the decimal equivalent of A is 10. So therefore instead of D minus A, I will subtract here 13 minus 10. So which is possible? The answer is 3. 3 is the answer of step number 1. So here in step number 2, what we have to do? We have to subtract D from 9. So this is step number 2. D 9 minus D. 9 minus D. That means the decimal equivalent of D is 13. 9 minus 13, which is not possible. When it is not possible or when subtraction is not possible, we have to take a borrow of carry from the next higher bit. Okay. So here in step number 2, so we have to take the borrow of carry from the next higher bit. So in the next higher bit, which number is available? 6 is available. That means when we give carry to the next previous lower bit, what will happen? So we have to subtract 1 from 6. 6 minus 1, that is 5. So here, therefore, instead of 6, it is written as 5. So here, let us come back to the step number 2. Okay. So here you have to add, since you have taken carry. So therefore, carry means 1 is equivalent to 16 in hexadecimal. 16 plus 9, how much it is? 25. 25 minus D. 25 minus D. See here, you can see here 9 plus 16, 25. So 25 minus 13 is how much? Why you have taken 25 minus 13? Because 25 minus D is the step 2. So how much it is? 12. So instead of 12, what I am writing? So I am writing the hexadecimal equivalent of 12. How much it is? C. So the answer of step 2 is C. So let us go back to the step 3. So in step 3, what actually 6 minus F. Okay. So we have given carry. So therefore it is not 6 minus F. It is 5 minus F. 5 minus F. So 5 minus F is possible or not possible? No, it is not possible, because 5 minus 15, it is not possible, because 5 is less than 15. So therefore, again we have to take borrow of carry from the next higher bit. So in the next higher bit, what is available? 5 is available. When you give carry for the previous bit, so 5 minus 1 is how much? 4. 4. So therefore, so it will be 4. So let us come back to the step number 3. Step number 3 is for 5 we have to add 16. 16 plus 5 is how much? 21. 21 minus f. 21 minus f is the decimal equivalent of f is 15. 21 minus 15 is how much? 6. So I'm writing here 6. So the answer of step 3 is how much? 6. So let us go back. Let us go to the next step. So in step number 4, we are supposed to take 4 minus 0. It is possible. So therefore, 4 minus 0 is how much? 4 minus 0 is 4 only. So therefore, so the answer, final answer for this subtraction is 4, 6, C, 3. I hope you understood how we can subtract in hexadecimal number system. Okay, still if you have any doubt, let me clarify in example 2. See, this is a small problem given. Example 2. This is the example 2 of hexadecimal subtraction. 578 minus 34A. Okay, I'm writing here bitwise. 875. Below that A43. So you have to write in the same order. Okay. So first LSB you have to match with second LSB. LSB of first hexadecimal should match with LSB of second hexadecimal number. So let us see what is step number 1. So step number 1 is what? We have to subtract A from 8. That means 8 minus A. Can you guess 8 minus A is possible? No. Why it is not possible? Because A is greater than 8. So what is the decimal equivalent of A? The decimal equivalent of A is 10. So 8 minus 10 is not possible. When it is not possible, what you should do? You have to take borrow of carry from the next higher bit. Okay. So in the next higher bit, 7 is available. So therefore, when you give carry, 7 minus 1 is how much? 6. So therefore, instead of 6, 7 is written. Instead of 7, 6 is written. So here, let us come back to the step number 1. So here in step number 1, see here, after taking borrow, this is 16 from borrow. 16 plus original 8, how much it is? 24. 24 minus A. 24 minus 10 is how much? Again, it is 14. 14. So the hexadecimal equivalent of 14 is how much? E. So therefore, the answer for step number 1 is E. Let us go to the step number 2. In step number 2, what you have to do? 6 minus 4 is possible. So that directly write as it is. 6 minus 4 is 2. 2 is the answer for step number 2. Step number 3, what you should do? In step number 3, so 5 minus 3. 5 minus 3. Okay, 5 minus 3 is how much? 5 minus 3 is 2. So finally, the answer for example 2 of hexadecimal subtraction is 2E. So this is the final answer. I hope you are following what I am saying. Advantages of hexadecimal number system. This number system is very compact, quick in operation, and easy to convert from hexadecimal to binary and from binary to hexadecimal. The number of digits used to represent a given number is usually less than in binary or decimal. It requires less memory to store more numbers. This number system is also used to represent computer memory addresses. It is easier to handle input and output in the hexadecimal form. So these are the main advantages of hexadecimal number system. So let us go to the multiple choice questions. So this is a question number. Let us see 1 or 2 examples of multiple choice questions. The number of question number 2, the number of digits in hexadecimal number is, how many digits are there in hexadecimal numbers? Number 1 to 15. Is it correct or wrong? No, it is wrong. F, wrong. 15, wrong. So therefore, the answer will be 16. The number of digits in hexadecimal number is 16. So in the similar way, so we can take another example of simple addition of two hexadecimal numbers. So let us compare the LSB of first hexadecimal and LSB of second hexadecimal. So addition of 3 and 6, how much it is? 9. So here we have 9. So the answer may be 1, 2, 3. And 2 plus 3 is how much? 3. So 3, 9 is the answer. Okay. So the additive result of two hexadecimal numbers 23 plus 16, which is of base 16, is 39. So the question number 7, the hexadecimal equivalent of binary number 1. So here the binary number 1 is given. So in binary it is called 1. What it is called in hexadecimal? Can you guess? 16, F, 15 or 1? 16 is wrong, F is wrong, 15 is wrong, but 1 is correct. So the serial 1 is represented in binary. The same one is represented in hexadecimal also. Okay. So for example, next, let us go to the another slide. Hexadecimal equivalent of a decimal number 8. 8 decimal. If you convert to hexadecimal, the answer will be again 8 only. So the hexadecimal equivalent of decimal number 8. So this is the 10 is wrong, 16 is wrong, 1000 is wrong. That is 1000. So therefore, so here out of 4 answers, first one is the correct answer. The hexadecimal equivalent of decimal number 8 is 8 only. So these are the answers for multiple choice questions. I have selected only 10 from these 3 topics. Okay, so you might find some other objectives from different topics. Okay, you can go through that. So these are the references. Okay, so number 1, Digital Fundamentals by T.L. Floyd, and second book, Electronics Principles by Malvin and Leach. Third one is Principles of Electronics by V.K. Mehta and Rohit Mehta. Digital Electronics by A.P. Godse and Dr. Deepali Godse. Okay, all these four books I have referred for developing this subject. And apart from that, using internet and Google search, I found some clarifications regarding this subject. And regarding e-sources, you can have from wikipedia.org/wiki. So this is our complete team who has supported for developing the content of the entire subject. So the main person is chairperson, followed by moderator, followed by subject experts 1, 2, 3, followed by content developer. So the content developer has developed based on the advice from subject expert, moderator and chairpersons. So this is our complete team. So therefore, I thank all my complete team, including chairpersons, moderators, subject experts, and other staff of this team who helped us directly or indirectly for developing this session and making this session a grand success. Okay, I thank for this entire team. And finally, I hope you followed my session, or my session is very clear to you. So suppose, in case of any suggestions, feel free to give suggestions regarding the content development or regarding the tools used for developing this content, or regarding the format of the PPTs, etc. For any suggestions in improvement or etc. So you can write to us lms.dtech@gmail.com. Thank you, one and all.